Have you ever thought of ice as solid water? Did you know that steam is water as well? Water, as well as other matter, can exist in three states or phases. We call them solid, liquid, and gas. As ice is heated, its temperature increases and it melts into liquid water. Likewise, as liquid water is heated, it evaporates into water vapor. These changes from one phase to another are referred to as phase changes. Did you know that the temperature of water doesn't increase when it boils? The water's temperature increases up to boiling and then remains constant as it boils. We will use diagrams that illustrate the relationship between temperature and heat to explain how this works. Before we do that, however, we need to describe the relationship between temperature and heat. Let's discuss temperature first. You are likely familiar with temperature as it is a common topic of conversation. We express temperature in degrees Fahrenheit, degrees Celsius, and even Kelvin, which is an absolute scale. But what is temperature? Well, temperature is a measure of how fast the molecules of a substance are moving. The faster the molecules move within the substance, the higher the temperature. For example, hot water molecules move faster than cold water molecules. Temperature can be defined as the average kinetic energy of a substance, where energy is the ability to do work. Kinetic energy is energy of motion, and thus reflects how fast an object is moving. The faster the object moves, the more kinetic energy it contains. The faster the molecules move that make up a substance, the greater the temperature of that substance. Now let's talk about heat. As substances are heated on a stove, in a microwave, or by the sun, energy is added to the substance. Heat can be defined as the total amount of energy contained within the substance. Where temperature reflects the average amount of kinetic energy, heat reflects the total energy. For example, 2 liters of boiling water has the same temperature as 1 liter of boiling water. However, 2 liters contain more heat, that is, more total energy. Now let's consider the relationship between temperature and heat. As substances are heated, the temperature increases. In other words, as energy is added to a substance, the molecules making up that substance move faster. Now let's diagram temperature changes in water as heat is applied to the water. This will help us to understand the relationship between heat and temperature. Looking at the diagram on the screen, you will see temperature along the y-axis and heat energy along the x-axis. You can see that the temperature increases as heat is added to water within a phase. In other words, the water molecules within ice move faster. However, temperature doesn't change as heat is added during a phase change. For example, when the ice melts. During the phase change, the added heat doesn't make the molecules move faster, but rather further apart. The heat energy added during the phase change is used to overcome some of the forces that hold the molecules together, allowing them to move further away from each other. So during the phase change, the added heat energy is stored as potential energy, or energy of position, as the molecules are now further apart. This is kind of like setting a mousetrap. Potential energy is stored in the mousetrap when it is set. In other words, when the position is changed. As heat is applied to liquid water, the molecules move faster and the temperature again increases. During the phase change from liquid to gas, the added heat is stored in the molecules as, once again, potential energy, and the temperature remains constant. The added heat is used to overcome the remaining forces that hold the molecules together within the liquid. This allows the molecules to move even further apart and form a gas. Once again, the heated energy during the phase change is stored as potential energy. Let's apply what we just learned about the relationship between temperature and heat to nature. Road crews will add salt to the road to melt the ice. Now, as we just learned, adding heat to a substance causes it to melt. So how does salt cause solid ice to melt into liquid water? Well, the answer is salt lowers the melting point of the water. The melting point of pure water is 0 degrees Celsius. Salt water has a lower melting point. And the more salt that is added, the more the melting point will lower. Therefore, the temperature must be colder to freeze salt water. A common misconception is that salt actually warms up the ice and causes it to melt. Salt does not change the temperature of the ice. Rather, the salt lowers the melting point of the water, causing the solid ice to melt. All right, then, what effect does salt have on the boiling point of water? The boiling point of pure water is 100 degrees Celsius. Salt added to the water actually raises the boiling point. In general, it is important to remember that impurities such as salt added to water will change the melting points and the boiling points of the compounds. In review, the temperature of a substance increases as it is heated. Temperature is the average kinetic energy of the substance, where energy is the ability to do work. Now, heat is the total energy contained within a substance. As a solid is heated, its temperature increases as the molecules move faster. During the phase change, when solid melts into liquid, its temperature remains constant, as the heat energy is stored as potential energy. Likewise, as heat is added to a liquid, its temperature increases as the molecules once again move faster. When the liquid reaches its boiling point and boils, the temperature remains constant, as once again the added heat is stored as potential energy during the phase change. Finally, impurities will change the melting point and the boiling point of the compounds.